In advance for my voice because I caught a bit of a cold, so my voice may be rusty. Sorry, but I will try to do my best. Okay, so today's theme is Browser Object Model, or BOM, and let's take a quick look at today's agenda. So first, I would like to recap what we have studied on the previous week, because we had, I hope, a very good weekend. We relaxed, and I would like to do a short recap of a document object model, the DOM, before we dive into the BOM browser object model today. Today we will talk about event loops, set timeout, set interval, location, history, as well as other properties of the browser object model. But before that, let's quickly recap the DOM. So, as we know, there is a global object called window, and all we did on our previous lecture was study the window.document, the document object model. So we have studied only one part. Now, what is BOM? What we will be studying today? It is also a special object on window which allows us to use several interfaces such as navigation, screen, locations, frames, history, and also do XML HTTP requests. So it shall be noted that when we are using window, we get access to both BOM and the DOM. The DOM is responsible for window document, and BOM, browser object model, is responsible for the other. Also, while we are recapping the DOM, let's quickly brush up on our knowledge on what are the nodes and node types, because from my experience, they are very easily to be confused, like what are nodes, what are elements. So window document object model. It consists of a hierarchy of nodes. So if we look at the example of this HTML, we can see that as a document object model, as DOM, it looks like a tree. We have the global HTML tag. Inside of it, we have head. Inside of it, the title, and the neighbor of the head is body, inside of which we also have the comment and h2 tag and a paragraph. All of them are nodes, but nodes, they can have several node types. So nodes are of several varieties. There are element nodes, like paragraphs, like divs. It's the element that we are the most familiar with, the elements which can be represented by HTML tags. So this is the main difference, like all elements are nodes, but not all nodes are the elements. An element is a subcategory of the node. There are also text nodes, as we have studied on our previous lecture, how we can change the text content inside the node. There are also C data sections. There are also comments, documents, document types, document fragments. There are many of them, but we are mostly working with elements and text nodes. So if we look at this quick example to really take this difference between nodes and elements, here we have the paragraph. And if we queue it, we can see that it's an element node. It returns true. And if we see if it's a text type, if we look at the first child in our example inside the P, we have the true. And document node type represents the entire document tree of nodes. It's our document object model, the DOM, window document. So document node type itself is a special one. It's a document node type. And if we look at our paragraph, remember we have paragraph and inside of it we have some text, we can see that the paragraph is both the instance of node, and because it's a node with type element, it's also an instance of HTML element. So it's okay for the node to have like two types, the parent type, the node, and the more specific type, the HTML element, the node with the element type. So paragraph is both of them. Also, during our previous lecture, we have studied the different methods and properties we can use both for nodes and both for elements. So for node, for example, we can call the parent node, the first child, the last child. Remember when we were appending elements to the DOM or prepending elements to the DOM. And Also, we can have the similar properties with children. So child nodes will list us all the child nodes, but paragraph children will only list us HTML element children. So these two comments are very useful. When you want to list all the nodes, and we remember that there are more than 8 types of nodes. There are HTML elements, there are text, there are document, there are CData, and so on and so forth. By running the command child nodes, you will see all of them. In our example, we will see both HTML element and the text. But if you want to list only the nodes which are type element or HTML elements, in other words, you can use another comment, paragraph.children. And here we can see that it will only return us one element, the HTML element. It will not return us the text. So this difference is quite useful, and I suppose you will be using it quite a lot. And also at the very last slides of the previous lecture, we have been talking about DOM event delegation. And I would like to return to this topic because it's quite strange at the first glance, but then it all makes sense. So let us consider the following example. We have a list, an unordered list, UL, and we have an on-click event. We have studied events on previous Friday, and we can track lots and lots of events, how user interacts with our application. The user can be clicking their mouse, inputting something from keyboard, so on and so forth. Tapping on something, doing right clicks, entering focus, losing focus. In this case, we are listening the on-click element. So what is happening? We have put this event handler on click on the list, but due to the event bubbling and propagation, as we remember, first the element is traversing from the window, the full HTML tag, down and down and down and down we go till the very last element, in our case, the li. And then it begins bubbling, propagating. And we are able, because the element is first going down and then going up, we can actually set our on-click handler instead of each individual li element on their parent, on ul. And if you run this code in the console, you could see that the on-click will be correctly handled when you are clicking on the li event. This is obviously very useful, and you will be using the event delegation extensively during your web development, because it's much more easy to set an event handler on the common parent instead of like breaking the dry principle. Dry principle, it's don't repeat yourself principle, and writing event handlers again and again and again. It's even more useful when you are appending elements on the fly, when you're appending them dynamically. For example, you're getting some data from the server with your list elements. For example, every list element is a post from Twitter. And instead of setting event handlers on each of one of them, you can simply add event handlers on their parent. So this is event delegation, which is made possible by the propagation of events, which we have studied. And now let us begin the theme of this lecture, the BOM, the browser object model. So the browser object model represents additional objects provided by the browser for working with everything except the document. Because document is for document object model, and we have studied previously. Let's look at the window. Window BOM gives us access to navigation, screen, location, frames, history, and also allows us to make asynchronous requests. What is a window in essence? Window is a root object. It has two roles. First, it's a global object for JavaScript code. When you were studying JavaScript core, if you have named the variable in global context, so you just have opened the file index.js and have written var foo equals var. This variable foo can be found as window.foo. So each and every variable or function which you have named in the global scope, because in JavaScript we have global scope, functional scope, and also the block scope. For example, the keyword var has functional scope, and the new keywords such as let and const, they have the block scope. So they are separated by the curly braces, not the function. So everything that you establish in the global window, then it will be found as window.foo, window.name of your function, etc. But this is only the first role of this global object called window. Secondly, it represents the browser window and provides our methods to control it. So to sum it up, global variables are properties of the window object. As we have discussed just now, if I have named a variable called foo in the global scope, then I can address it later as window.foo if I desire to do so. Global functions are also methods on the window object. And even the document object, what we have studied previously, the HTML DOM, is a property of the window object. So these two commands on this slide, they are totally equal. We can both call window.document get element by ID or just document get element by ID. They are both working exactly the same, so it's considered redundant to use window. And usually we are just writing document as we did in the previous lecture. But you shall remember that document is just a part of the window object itself. Window allows us to use several commands directly on it, and you will be using these commands extensively in web development. So window methods include inner height and inner width. It will allow you to see the height and width of the browser window. So for example, when you are making a responsive layout so that your website is looking nice both on big screens, small screens, on tablets, on mobile devices, you shall be taking into account not only the type of device, for example, my Apple iPad or iPhone, but also the size of my screen. For example, if I'm using a very small window laptop, maybe my site shall be looking a bit different from when I'm using an extremely large widescreen monitor. So by tracking the inner height and inner width of the browser window, you can adjust your layout by using mixins, by using media queries as you have studied in your HTML lecture. Also, we can program to open a new window in the browser or even close the current window. This is very useful when we want to make our user to redirect to other website. Usually this action is considered unsafe, so there will be a prop like, do you really want to leave this website? I suppose you've seen such props a lot while surfing the web. And if you click OK, then you will be redirected to a new window. For example, if you need to tell Google that it's actually you, even though you're logging in from another location. For example, you're on your vacation currently. And then a special new window will open and it will ask you, hey, can you please push this button on your phone and tell us that it's really you. And after you have pushed the button on your phone, the window in the browser will automatically close and you will be redirected to another site that you initially desired to go to. Aside from opening and closing the windows, you can also move the window or even resize it if you so desire. So the most common methods you will be using are inner height and inner width, but sometimes open and close methods can also be useful, depending on what business wants to do with the feature. Next, the navigator, the window.navigator. This interface represents the state and identity of a user agent. I would like you to remember this term, user agent. It's how we usually call the visitor's browser, so just so that you are familiar with it and do not get confused in the future. So user agent is like Firefox, Chrome, Safari, so on and so forth. So Navigator interface allows us to query the user agents to register themselves to carry on some activities. And Navigator object can be retrieved using the read-only window.navigator property. So using the window.navigator, we can only see some data. We cannot change anything. So it's only a getter. We cannot set anything. We can just view the data that it gives us access to. We don't have any write properties. So what can we do? For example, we can see if the cookies are enabled on this website. This is especially useful given that currently cookies are tightly regulated by the government, and you shall always be asking your users, is it okay if you'll be using your cookies? Is it okay if you'll be using your location? Is it okay if you use your personal data? And so on and so forth. So if cookies are enabled in the browser, because some users can deselect them on all websites, then you can present your user with a pop-up saying, hey, we would like to collect cookies in order to make your user experience better while using our website. Are you okay with that? And if they're okay, then you can begin collecting cookies. App name. Navigator.appName returns us the application name of the browser. So you can see what this application is called. And Navigator product, it also gives us the name of the browser engine, because browser and browser engine are not the same. For example, Chrome uses the V8 engine, and the same engine is being used by Microsoft Edge, and so on and so forth. There are lots and lots of methods available for window.navigator. I did not list them all here because I don't think that it's necessary at this stage. But if you see in your future work that you need to do something with the window.navigator object, the full list can be viewed at the MDN, at the API Navigator Standard Properties section, which I have linked here. Next, the screen. Window.screen contains information about the user screen. Once in a while, our names can be logical in front-end space. So what can we do? We can return the width of the screen in pixels or the height. We can also do some more specific command, avail width and avail height, which returns the width or the height of the visitor screen minus interface features like the Windows taskbar. So they can be used to when you don't need to calculate the Windows taskbar, when you need to see like, what exactly is in my viewport? What would the user can see? How can I adjust my application for this and this width or height? There are also several properties for color depth and pixel depth. They are a bit deprecated because for modern computers, we are almost all using 32-bit hardware for color resolution. And for modern computers, color depth and pixel depth are equal to each other. But if you are developing software for more legacy machines, it can be useful to know if the machine your users are using to access your website, it does not support this and that colors, and maybe you should make your color contrast ratio a bit higher so that it looks nicer on old machines. But currently we are mostly using screen width and screen height. Next, location. Location, it allows us to solve two very common tasks: to know our current location and to set our new target location, like where we want to redirect our user. What is location? Location is our URL, what you see in the browser at the top when you are navigating the website. So let's analyze an example URL. First, on the left, you can see the protocol. It can be either HTTP or HTTPS. HTTPS means that your connection is secure. So HTTPS is a sublayer protocol which handles your requests differently. They are not being passed through the open web without protection. They are being secured. So, for example, it's very important when you are inputting your credit card data to pay for something on the internet to note that you are not sending your credit card data via the HTTP protocol, because if it's not secure, then some malicious software can be put in the middle between you, the sending side, at the website, the receiving side, and then uh, other people will get access to your sensitive banking data or personal data. So currently, by law, the websites are required to use the HTTPS, the secure channel, for sending all data. And it's also a good idea while you are just surfing the web as a user to always make sure that you have HTTPS enabled when the website is asking for you to input any sensitive data, especially your credit card credentials. Next, we have the host name, for example, amazon.com or google.com or epam.com, anything. And obviously, www, the World Wide Web, as we all remember it. Next, there is the port on which we are running, because when we are accessing our website, there are lots of ports we can connect to. And then after the slash, there is the path. So when you're on amazon.com, inside this host name, we have lots and lots of pages. And aside from pages, there can also be queries. For example, let's analyze this. So after the slash, we have s question mark key equals edge plus of tomorrow, and reference is something, 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 and hash search. So when we are listing some things on the path, it makes it easier for the website to remember what you have input inside. For example, here, for example, I suppose key equals the query. So for example, you are searching the edge of tomorrow. And after you have input edge of tomorrow into the search input box, it has been added to the path, which allows the website, when it redirects you to another page, to analyze the query again and see, this person has just been searching for the age of tomorrow, so let's provide him with information he shall desire. And if you are having several parameters in your query, then you are separating them by the ampersand. So the first one is a question mark, so question mark K, then equal sign, and then we have the edge of tomorrow. And after tomorrow, you can see the ampersand or the and sign, and then we have ref, the name of the parameter equals, then the value of the parameter. If you would like to add a third or fourth or fifth parameter to your query, you will be using the ampersand sign again. And at the very end, we can also be adding several hash tags. For example, here, this is the search hash. And together, the protocol, the host name, and the port, they make up the origin of our website. All these three parameters combined together. So if we go to amazon.com and input its location in the console, we can see that there are lots and lots of things which are accessible via the location object. So we can easily see the things that we have just discussed previously, the hash, the host name, the origin, the path name, the port, the protocol that is secure HTTPS. And we also have several methods. Their names kind of speak for themselves. For example, reload, replace, search, convert this to string, get the value. Replace is a method that is being used very frequently. For example, you need to replace something on the query. So, for example, the user has logged in Amazon.com and you would like to store some information about their profile. For example, their preferred language, if it's not the same as their browser, or their unique profile identifier, so that each page of your website knows this profile identifier. I can adjust its contents to make it better for this current user. Then you can just replace the query, add the parameters you desire, and you can also delete parameters from the query. So you will be changing the contents of the query extensively during your web development work. We work with queries a lot. And this object on window provides us opportunities and methods to do so. Next, hash inside the allocation. Having a hash value in the URL, it allows us to scroll to the relevant part of the document. So, for example, with Amazon.com, we had hash search. So if user copy paste this link, or for example, if I share this link with you, then you open it and you will go to the search results for tomorrow, and the page will not be scrolled to the beginning, but it will scroll exactly to the search. For example, if we are looking at Wikipedia, I suppose you have noticed it that nowadays we can share not only the whole page, but also use the so-called anchor on the page. to share the link to specifically the name of the article or the name of the paragraph, the section that we desire. For example, here I can click on the examples and the URL with update with hash examples, and I will be able to share exactly this part of the page with my friend whom I will send this link to. This is very useful and allows us not to get lost in long pages. So it shall be noted that hash may be totally harmless at the first sight, but there are lots of possibilities we can use it for, and with possibilities, obviously and sadly, comes a lot of bugs. So, for example, let's imagine that there is a request from the product owner that the page should scroll to a specified position after the page loading. For example, hash search. So even though the hash can be used for that, if the browser is concerned to decide how and when to process that, because it's part of the browser API, like we are studying browser object model today. So this could lead to unpleasant surprises. For example, window scroll to method. It just tells us the coordinates, the x coordinate and y coordinate, or when to scroll it. But it is very hungry for resources on your page. So if you have lots of windows scroll to, then the browser will be constantly calculating and recalculating the current position. And this is very taxing on resources. Hash can also be used for special purposes, for example, communication between iframes. Because lots of time when you are developing, you will need to integrate third-party frames on your website. So you shall be very wary on when you are using the hash, because browser object model, as it stands from the title, it is not the same between browsers. Document object model, it's part of the standard, so you can be sure that DOM methods will be working the same in all browsers. But for browser object model, the browser methods, they will be behaving differently for Safari, for Firefox, and for Chrome. Not all of them, but several. And also some methods which are already supported by a new version of browsers, because new versions are releasing constantly. For example, Google Chrome is now like on what, like 98 version. They are rolling new versions out every 2 weeks. For example, Microsoft Edge browser is updating at a much slower pace. And for Internet Explorer, its update path has been closed for several years already. So obviously the browser object model of Internet Explorer does not support many cool features. If you are unsure which browser is supporting which BOM methods, you can always reference websites such as caniuse.com, which will help you see, is this feature supported in this browser, and if yes, up from which version it is supported. So it can be very useful when you are developing to make sure that you are covering all the browsers that you shall be supporting in your application. Next, location, navigate. So when we are setting the location.href parameter, the browser will navigate to a new URL. Navigation could also be possible with location.replace, same as query.replace. But the difference is that location href will save the original URL to the browser history. So here we can see the location. We can set the location href, and then we will have navigated from .amazon.com to EPAM.com. And also history. Let's talk about frames and then the browser history, because even though we are using mostly single page applications right now, we are still using browser history extensively for the better user experience. So window frames, it's a bit of a tricky one. So don't worry, today we are mostly studying it just to know. You will not be using window.frames frequently. These slides are mostly there just so you are aware that window.frames exist. So window.frame returns the window itself it's an array-like object listing the direct subframes of the current window. So each item in this array-like object, the window.frames, it represents the window object corresponding to the given frame or iframe content. So, for example, if we look at the window frames, we can do then something with each subframe. Window.frames will be useful for you when you are working with iframes in your website. Just know that they exist and you can always return to this topic later when you really need it, because frames are not used frequently and I don't think that it's fair to burden you with this knowledge just now. We already have lots and lots to learn. So let's return to browser history. The browser history can be modified. We can also perform several actions. For example, if you remember, at the top of your browser, you have buttons. Return, go forward, see the home page, and so on and so forth. So location gives us our current location. Then if we call the history back method, remember now we are at epam.com, then we have returned to amazon.com, and then we can manually call the history.forward method in the console, and then we will navigate back to epam.com. Even though when writing in React or in Angular or in Vue, and you are using client-side rendering, you will be not actually navigating between the pages, because as we have studied with the single page applications, you are receiving HTML only on the first call. After that, using Ajax, you will be receiving data in the form of JSON. And then you will be partially updating the page and it will not be reloading as a whole ever again. But for better user experience, as lots and lots of users are familiar with back buttons, forward buttons, and just seeing that the query in the browser has changed, the URL has changed. When we are writing SPAs, single page applications, we are actually changing these parameters despite staying on the page. So for example, if you go to react.js.com, this page is written in React, it's a single page application, but if you, for example, click on navigation and then you click on some section and then you begin reading the hooks article, in URL you will see like react.org/navigation/articles/hooks. So using the React router library, the URL path will be updated. And also after you navigated to another page, you can still click the back button in your browser and you will be correctly redirected to the previous page, the hooks, even though it's not actually a page in a technical term, because we are using single page application, SPA, and we are not reloading the whole page. But we are artificially adding these updates of the page to the browser history so that the experience is much more familiar to the end user. So SPA and MPA allow us to process things differently in technical perspective, but we are still actively using the browser history to make user experience better. So let's talk about mobile applications regarding history. Usually on mobile, because the screens are much smaller, we have less navigation elements. So this will need special attention to handle property, because there's lots and lots of edge cases, especially given that just the same as web browsers, on mobile we have, for example, Android, and there are lots and lots of different Android versions. Like, for example, only Google Pixel is using raw Android. All other major players on the market, for example, Samsung, Sony, OnePlus, Huawei, so on and so forth, they are using their own wrappers around Android software with their own UI, and it can be a little tricky to correctly use browser history on mobile. And also, this is not even taken into account the iPhone. They have their own operative system. And now we are beginning to talk about maybe the The most complicated topic of today's lecture, the event loop and set timeout. Now we will be talking about the request and how JavaScript processes asynchronous code. So, my first question to you will be, when you studied the JavaScript core, did you study the event loop and set timeout functions? Did you have such a lecture? Okay, I suppose the silence means that you did not, so let's take this slowly, step by step. So, JavaScript is a single-threaded language. It means that all operations are executed one by one. No operations can run in parallel. And when we are executing JavaScript code, the interpreter, because JavaScript is not a compiled language, it's an interpreted language. The interpreter is looking at our code from top to bottom, and it's giving the code two passes. First, it's running through the code and indexing everything that it sees. This is where the hoisting stage appears in JavaScript. Because in JavaScript, the variable names and the function declarations, the functions which we have declared using the keyword function foo, they are susceptible to hoisting. So, for example, if you write in JavaScript code which looks like this, let me just write it in the chat. So, for example, if we try to run a console. So if you write something like that, first we will invoke the console log from A, and next we will actually declare the A variable which equals to 5. What will occur is that during the first stage, the interpreter is running through the code and it's doing the hoisting. So it will hoist the A variable that it exists, that we have the variable with the name A, but it will not hoist its initialization. Initialization means that we are adding a value to our variable. So how it will look from the interpreter perspective. First, we will have variable A, then we will have console log A, and then we will have A equals 5. So here's how this code is looking from the interpreter perspective. It will hoist the declaration of the variable, but it will not host the invocation of this variable with the value 5. And so if we run this code, the console log will actually give us undefined, because all variables which are invoked using the keyword var, they are first invoked with the undefined. So on the first line, where we just writing var a, as interpreter sees it, we are already declaring this variable with the undefined value. Then we are console logging it with that value, and then when we are telling that this variable shall hold in itself the value of 5, this has not moved inside our code base. So we will not see 5, instead we will see undefined. And also the same goes for function declaration. So for example, if I write a code like this, so here's a very, very simple function. So I have here function foo, which just returns a 0. And function declarations is when we are declaring the function using the function keyword, because we can also write the same thing using a function expression, for example. So this one is a function expression, variable foo equals function. This next one is a function expression. So function declaration, I can call it like that. So our function declaration, the function foo, it will hoist as a whole. It will hoist as a whole function with its body. And so I can first call it and then reference it later down the code, and everything will be working properly. let me just put this function declaration, and this one is a function expression so that you don't get lost in the future. So, and next one is a function expression in the chat. So when we are calling function declaration before it's written in the code, everything will be working fine. Let us also write this in the chat. So this will work correctly in the function declaration example. But with the function expression example, we will actually get an error if we try to call this function before it's invoked. If you try to do something like that, first call foo and then initialize variable foo, which is equal to a function, we will get an error. Why? Because actually, let's see what is happening there from the interpreter perspective. So first we have call of function foo. The calls are not accessible to hoisting, so it stays where it is. But then we have the hoisting appearing, and there will be a variable foo. But again, when we are assigning a value, the value assignment is not being hoisted. So from the interpreter perspective, this code will look like this. First, we are declaring variable foo, and we remember that at this stage, this variable foo is equal to undefined. Then we are trying to call it, but it is undefined, and undefined is a primitive value. It cannot be called. So when you try to run this code, you will receive an error. Foo is not a function. Because from the interpreter perspective right now, inside our foo, we have just an undefined value. And only then we are actually assigning its value, and its value will be a function. So that's the main difference between function expression and function declaration. And all code in JavaScript is run subsequently. It's a one-threaded synchronous language. But obviously, this is not very useful when you are writing web applications, because when you are on a web page, there are lots and lots of things happening at the same time. For example, you are sending some requests to the server. While you're waiting for your request to be done, the page should freeze, the clicks will not work, the keyboard input will not work. No, that's not good from a user experience perspective. So in JavaScript, despite it being a single thread, all asynchronous things, they are being handled separately. And all browser-related things, all XML requests, all server requests, all browser events, which we have studied during our previous lecture, for example, all user clicks, mouse events, everything like that. All operations with DOM, for example, appending nodes, rendering nodes, changing nodes, these all operations are considered asynchronous because they are not happening momentarily. There is a slight delay. So how is this working that we have two separate queues in JavaScript, the synchronous queue and asynchronous queue? Let's look at the scheme at the right side of the slide. What we have explained right now in the chat regarding the hoisting and the synchronous code, it's being executed in the call stack. The call stack is using a data structure called a stack, and it's working based on the principle first in, last out. What does it mean? If I see a function in my code, which is something like this. So for example, we have function and inside of it, we have something like return function. And inside of return, we also have 0, for example. So if we encounter such a construction inside our JavaScript code that I have a function foo, and inside of it, I have the bar function. So what will happen? First, we will put the function foo on the call stack. First, our call stack is empty. Then we look inside of our foo function and we put it on the call stack. So our call stack will look like this. But then we see that inside of the foo function, there is also a bar function. And because the stack operates on the principle first in, last out, we are actually adding the bar function on the top. So it will look like this. First, we will see bar and then foo. So the bar function, even though it was added later, it's now first to be executed. Then we are looking inside the bar function. If there was another function inside of it, we will also put it on top of our call stack. But inside the bar function, there is only return 0. So we are executing the bar function. After we have executed the bar, then we remove it from our call stack. So call stack after bar execution will again look like this. We will only have foo function on the call stack. And after we have executed the foo function, we also remove it from the call stack. And now the call stack is empty and we can move forward to the next function in our code. But in parallel to all of this, we are running our asynchronous function. And whenever an async function is called, it is sent to a browser API. So JavaScript itself is handling only the synchronous code. All asynchronous code is being handled not by JavaScript itself, by either the browser or the node environment if you're running JavaScript not in the browser but on the node. Today we're talking about the browser. So whenever an asynchronous function is called, it is sent to a browser API. These are the APIs built into the browser itself. Based on the command received from the call stack, the API starts its own single-threaded operation. And a good example of this is the setTimeout method. So when a setTimeout operation is processed in the stack, it is sent to the corresponding API, which waits till the specified time to send this operation back in for the processing. And how it is all working. We are not sending our synchronous events to the call stack. This one is only for the synchronous code. We are sending them to the event queue, which in itself is separated to microtasks queue and tasks queue. You can see them on the scheme at the bottom, microtask queue and task queue. So after we have sent our asynchronous task to an appropriate task queue, we have a cyclic system for running async operations in JavaScript. As we have talked before, the language itself is single-threaded, but the browser APIs act as separate threads. And what makes all this process tick is the event loop. So event loop facilitates this process. It constantly checks whether or not the call stack is empty. And if it is empty, new functions are added from the event queue. And if it's not, then we are running our synchronous code. Now that we have discussed it, let's look at this scheme again. So in JavaScript, we have two big chunks of code. The synchronous code, which is handled by the JavaScript itself and being put on the call stack, as we have just discussed. And the asynchronous code, which is handled not by JavaScript itself, but by the browser API. So what is happening? For example, let's look at some synchronous and asynchronous code. Let me put it in the chat. Let's see if we have some code with both set timeouts, promises, and synchronous code. What will happen? Here's this code. Let's see. Here we have both synchronous and asynchronous code put together. The first part of the code is synchronous. variable a equals 5. Okay, this can be handled by JavaScript. Okay, JavaScript is interpreted, so we have run this code, we have declared a variable called a, and we have initialized it with the value of 5. Next, we encounter setTimeout function. SetTimeout function, as we have just discussed, it's an asynchronous function. It's not being handled by JavaScript. So instead, we are sending it to browse API. The setTimeout function is being put in the tasks queue. Next, we still have the synchronous code. var p equals new promise. Promises themselves are asynchronous, but as of now, we are just declaring it. So set timeout, we are running it. But promise, we are just declaring it. We are just writing that this and that will be the promise. So by now, it's still synchronous code. So var p equals new promise. And inside of it, the promise is a function which accepts two arguments, the resolve and reject. Then there is the body of the promise, what it will do. And then after we call resolve and brackets, then we are in the asynchronous territory. So when we ask the promise to resolve, then this code becomes asynchronous. Okay, so we have run all this synchronous code. We have initialized the p, the variable with the name p, and then we have assigned that its value is a promise. But then we encounter in the code the call of the resolve function, and this code is being put again in the browser API. It will be a microtask. All promises are microtasks, and set timeouts and set intervals are tasks. And we will be studying this in more detail during our next lecture. So, okay, we have put the promise on the asynchronous queue, and then we have the syntax called p.then. .then is also a promise syntax. It means doing something after the promise is resolved. Resolve is an asynchronous code, so .then is also synchronous code. Okay, so we put this p-then on a synchronous queue, and then we have our synchronous code, console log.a. So if we separate this code to synchronous and asynchronous, synchronous code will be with this. Synchronous code will be var a. Synchronous code will be this part. Var a equals 5. Next, we are declaring var p, which is equal to a new promise. We are creating a promise, but you may notice that I have deleted the resolve method because resolving promise is asynchronous and it will be run in the browser API, not by JavaScript itself. And then we have our final console log. So this is the code which will be run synchronously by JavaScript. And in parallel, we have our asynchronous code. Our asynchronous code will be set timeout and promises. And as we have just discussed, promises are set to the microtask queue, and set timeouts and set intervals are being sent to the microtask queue. Microtask queue have more priority than tasks. So let's see how it will look. So we will be resolving our promise. Here's how it will look. Asynchronous code. We have our promise, which we resolving right now. So we resolved it. And after we resolved it, then we are running the then part of code, the p then, console log then a, and these are the microtask part because they are related to promises. And after everything related to the promises is run, we are actually running the code for the set timeout. Suppose that at the beginning, the event loop part can be very, very confusing. So let me just link you an absolutely amazing talk from the JavaScript conference by Jake Archibald explaining what is event loop. And I highly recommend it to you that you listen to his presentation. It has amazing animations, which helps us understand how this whole structure works, because we are not even finished yet. I've linked the conference video in the chat. So as of now, we have looked at the call stack, the microtask queue, and the task queue. But we are not even finished yet, because we have the third part. We actually have the render part, as you can see on the right. We have the rough request animation frame function, style recalculate, layout, and paint. If you remember when we were studying the document object model, the DOM, we are handling all operations with the document, with the DOM nodes. They're all asynchronous. So actually, it shall not be surprising to us to find everything related to document object model here in the asynchronous part. So when we are receiving HTML code from the server, as we have discussed in our previous lecture, we receive the HTML from the server, and then we are building the document object model. Then we are building the CSS object model, CSSOM. Then we are combining DOM and CSSOM together, and we are getting the render tree. And this is what? These are the nodes ready for render. We already know their hierarchy, and we already know the styles to be applied to these nodes. And this is all the part of the critical rendering path. Moment, let me also find a good article I have saved and link it in the chat as well, the critical rendering path. This is how our browser is rendering our page, because it's happening not synchronously, not momentarily, but in stages. So first we are building the document object model, then CSS object model, then we are combining them together into the render tree, then we are making the layout. So if we look at our website, we can see how much space each block is taking. Like, for example, at the top we have navigation, at the bottom we have our footer, in the middle, we have a list of cards, for example, of movie cards or of our posts on Twitter or our rectangular post on Instagram and so on and so forth. So before painting actually any pixels, we need to understand where we will be painting them. And this is called building the layout. So there are no beautiful pixels yet, but we already know that these DOM nodes, they will be displayed here at the top, this under them, this under them. And after we have calculated the layout, then the last stage in the critical rendering path appears, the paint stage. Paint stage means painting the pixels themselves. And all of these operations, they are also asynchronous. So for example, when your browser is loading some heavy image, you can still operate with your website. While this image is loading, you can still scroll, you can still open and close forms on the website, you can click on drop down, so your website is not frozen, because the operation of painting the pixels of this heavy image is asynchronous. And the render part of asynchronous operations is also handled by the event loop. So if we take a look at the bottom left side of the scheme, we could see that event loop is managing tasks, microtasks, and render. So in the example that we have just discussed, where we were separating the synchronous and asynchronous code, when JavaScript understands that this code is asynchronous, it's just been sent to the web API, and from then the event loop mechanism is analyzing it. So, var p equals new promise. Okay, this is a microtask. Put it in a microtask queue. And queue is based on the data structure called queue, and queue is operating as we are all familiar with. For example, when you're standing at queue at McDonald's, first in, first out. The first person who is in the queue will be the first one to be served. This is totally different from the stack, because as we have discussed in stack, the last one to come in is the first one to be served. So all asynchronous code is running in a queue format. All synchronous code is running in a stack format. When event loop encounters a microtask, it puts it in a microtask queue. And at the same time, it's constantly checking how things looking in the call stack. Because if we look at the chat, when we had several functions nested inside each other, we had our foo function and bar function. And we were writing that in the call stack, we have both bar at the first place, because it was placed there last, and then the second place foo. So the call stack is not empty. We are currently running our synchronous code. JavaScript is running it. So event loop is waiting, like, call stack is not empty. No, I cannot execute this microtask. Keep managing the next tasks. Then, in our synchronous code example, it encounters the set timeout function. Event loop analyzes it. Set timeout. This is a task. Let's put it in a task queue. If it encounters then another promise, it's like, microtask. Put it in the microtask behind the previous promise. Next set timeout. Put it behind in the task queue. Oh, we have to load a new image. Let's put it in the render task. Or the user has moved their scroll button, because when you're scrolling, your viewport is changing. So we actually have to render everything again. Everything's new on your screen. Okay, I need to call the request animation frame function because the contents of the screen, they have changed. The user has used the scroll button. What request animation frame does? This function, it collects all the information about the changes that has occurred. Probably you know that the human eye can only see about 24 frames per second. That's why several years ago there were lots and lots of things about seeing something on a 25 image per second, and it will somehow affect you. This is false. So it's impossible to manipulate us using the 25 image in 1 second, but still our eye can only see the 24 frames. So lots and lots of things can happen during 1 second, more than 24 frames. So our monitors, they have something called the hertz. Your monitor is updating not based on each and every event that has occurred. So when monitor is updating its view and contents, it's taking note of everything that has happened after its previous tick of updating. So the monitor has updated, you've seen your pixels on your screen, then lots and lots of things have happened. This part was moved, there was a pop-up window, something. Obviously this happens really quickly because if you look at the monitor, it's like 60 hertz they are updating, so still they are updating lots and lots of time, but not like each and every nanosecond. It's updating in milliseconds, so it looks smooth to a human eye, but we still have performance optimization so that the monitor does not start repainting our pixels after each and every small change. Instead, we are putting all these changes in the render queue. And when the next render tick happens, like, hey, it's time to update everything on the monitor screen, like several milliseconds have passed, let's update. Then we are processing all these render changes at the same time. And event loop is a mechanism which is putting everything in its correct queue, set a interval, set timeout, go to tasks, everything promise related goes to microtasks, everything render related goes to render. Okay, they're all in queues. And now let's check our call stack again. In the time it took us to sort everything together with tasks and microtasks and render related tasks, we have successfully executed the bar function, we have executed the bar function, and we have the foo, the only thing left in call loop. But if we execute the foo function, then the call stack will be empty. Let me put it in the chat. So after we have executed the outer foo function, the call stack is empty, and this is the time for event loop to act out. So it says like, hey, call stack has emptied. We have executed this portion of the synchronous code. Now is my time. So it puts the first thing from the microtask queue and executes it. Next comes the important difference between the microtasks and tasks. Let's for example, see that in microtasks queue, we have some promises. We have, for example, two of them. So after call stack has been emptied, there is no synchronous code to run. First, event loop will navigate to microtasks because they have the highest priority, and it sees two promises. And in microtasks queue, all tasks will be run when it's empty. So when tasks will be run, code can be run again. Let me just put it in the chat. So this is extremely important. Remember, as we talked before, you cannot freeze your page while your image is loading or while some set timeout functions are running, but you can actually freeze your page using promises because all microtasks will be run before synchronous code can be run again. So if you will decide to run some code with promise, which will be executed, for example, while is true, it will be executing indefinitely. Let me find, for example, here's a good example from Stack Overflow. So if you, for some scientific purposes, create a promise which will be running indefinitely while true, this will always run. It will not stop. This condition is always true. So what will happen is call stack is emptied after another portion of the synchronous code is run, it's empty, and then event loop begins feeding it the microtasks, and it will keep feeding them until the microtasks queue is empty. But if you have created an indefinite loop with while true inside the promise, then there will be more and more and more and more microtasks being added, and the queue will never stop. And because microtasks will be run till the microtasks queue is empty, and in the meantime, no synchronous code can be run, your application will freeze. So please be aware of that when you are working with promises, because promises, them being microtasks, can actually freeze your application. But let's see an example where everything went fine. We have executed both our promises. We did not enter a never-ending loop. And now the microtasks queue is empty. Next, event loop checks again. Is there any code on the code stack? If all of our code consisted of these two functions, foo and bar, by now they have been executed and we are free to go. If there was other code, synchronous code in our files, then it will be run. Like we will look inside the function, we will put everything on the call stack, execute everything, and then empty the call stack again. As soon as call stack is empty, like we have this window, this pause where event loop can act, the event loop is like, hey, I have several tasks for you. We have set timeout. And here's the important difference between microtasks and tasks. Let's see, for example, we have the tasks queue. So, for example, we have the set timeouts here, set timeout. And when call stack is empty, only one task will be run. This is the main difference between tasks and microtasks. One will be run before synchronous code can be run again. So event loop checks. Call stack is currently empty. Okay. Microtasks queue is empty. Okay, let's go. We switch to tasks. Then we execute the set timeout, and then event loop is checking the call stack again. And if there is any code to be run on the call stack, it will run it, and then it will return to the task. So tasks are usually slower to be resolved than microtasks. But you can be totally sure that even if you write the while true loop, the indefinite loop using set timeout, yes, it will eat up your resources because something will be constantly running in the background. But even with while true set timeout loop, nothing bad will happen to your website, like it will still be running. So let me find. So yeah, I'll put it after the lecture, I suppose, just to not take any time right now. But if you write something like while true and run your set timeouts, nothing bad will happen. The applications will not freeze. But still, this leaves us with the render part. As we have discussed, the render, it is being handled by how frequently your monitor is updating. It's not updating after each and every change. Instead, it is based on the speed, like 60 hertz, 120 hertz, and so on and so forth. Again, here is a good article. So this is the article of the refresh time. So as soon as this time has passed, for example, your monitor is updating with 60 hertz, as soon as the tick passes and we reach a moment where call stack is empty, regardless of tasks or microtasks, we are putting next render batch update there because 60 hertz monitor requires us to update at this moment in time. And then we are just counting these ticks like, hey, the time has passed, we need to update everything that has happened. Update and it also then do like microtask or put there a task, then again change the call stack. So this is quite complicated orchestrating process, but event loop is handling it really well. And together the call stack, the microtasks queue, the tasks queue, and the render queue, all of them being orchestrated together by event loop allows us to have a smooth developing experience and also for our users, for end users have a good end user experience. And now let's analyze the functions that we have been talking about in more detail, the set timeout. So let's see. For example, we have a function cage says, which is just put into console log. What I'm about to tell you sounds crazy. And then we are creating a set timeout function. As first argument, it accepts the callback function, the function that it will execute. And as the second argument, set timeout accepts the number of milliseconds after which this function will be run. So at the first glance, we would think that after a delay, it will execute our code. But actually, this is not true. This is not what happens under the hood. So the set timeout does not actually wait to execute our code. Instead, it's asynchronous. So the most important part to understand here is that set timeout does not actually wait. When we set a callback to be executed, it actually does what the name suggests. It only sets up the timer and the execution continues without any waiting. So when will our function will run? So it will run after a 500 milliseconds delay, but when exactly? let's see at the synchronous and asynchronous code in our example. First, we have the cage stays, then we wrap it in set timeout with 500 milliseconds delay, and then we are putting the synchronous code, just the synchronous console.log, but you have to listen to me. And if we run this code, first the synchronous code will be run, but you have to listen to me, will be console logged. And then what I am about to you sounds crazy. So did it actually execute after 500 milliseconds sharp, or did something happen? Let's see how to implement a sleep function in JavaScript. Sometimes you need to make your code run at a later point in time. So let's see how it can be implemented. If we try to implement function sleep, which accepts delay and initial time, and then we will see while a date, now it's the current date, is less than initial time and delay, then we will be logging for you judgment day, or on click, we will be console logging what day is it. So if we try to click as much as we can on the window object, it will not click lots of the time. So we are clicking currently, but we have blocked our browser. So this is a synchronous code right now. Yes, like function sleep, it's synchronous. And as we have discussed previously, we are being put on the call stack. So function sleep is running. It's running indefinitely until we hit like our judgment day. And while it's running, our window is unresponsive. So this is how we can block our window if we are not using asynchronous code. Our while loop is running and our window is unresponsive. So only until it has logged out the for you judgment day, only then we will be able to see all the clicks that we have done. So we have been registering the clicks all this time. We were just not able to display them because the call stack, the synchronous call stack, was being used by the while loop. So after for you judgment day is printed to the console, next we receive 90 instances of what day it is. Is it? The synchronous code is now being able to run correctly, but this is not the behavior we were hoping for, because while this while loop was running, we were not able to interact with the window correctly. Okay, let's change our sleep function and try to do it with the set timeout. Here we still have our function sleep. It's the same. Next we have the function cage says. We have the immediately invoked function expression. It's where we wrap the function in the braces, and then we are also adding the opened and closed braces at the end. This means that our function will run at the same time as it's written in the same part of the code. So it's immediately invoked, hence the name, immediately invoked function expression. So what are we doing? Function, inside of its body, we have set timeout with cage says and 500. Then we have our synchronous sleep function, and then we have again the synchronous code console log, but you have to listen to me. So first we have a 500 milliseconds waiting for set timeout. After we reach the sleep part, by then our set timeout should have run because it's only 500 milliseconds. So every console log should run according to the numbers. So it will be 1, what I'm about to tell you, 2, but you have to listen to me, and 3, your very lives depend on it. Let's see what actually happens here. I see the quest finish with this example, and then we will analyze the code from the chat. Okay. So Let's see how set timeout is. So it's to wait until the function is finished. But the console log placed outside the function, it runs before as well. So let's say first we are executing the second console log, but you have to listen to me. Then we execute the third one. Your very lives depend on it. And then we only execute the set timeout part. What I'm about to tell you sounds crazy. So what is actually happening there? Why is it looking like that? As we have discussed when analyzing the event loop, the synchronous code, asynchronous code, in this example, because all the code is synchronous apart from the set timeout, like cache says function expression, it's synchronous code. Inside our immediately invoked function expression, only set timeout is asynchronous. So it will be handled to the browser API, and then it will be handled by event loop and put in the tasks queue. Everything else is being put on the call stack. So yeah, first we will execute the, but you have to listen to me. Then we will execute your very lives depend on it because it's all synchronous code. It will be run first. And only after our call stack is emptied, only then we will execute our synchronous code. What I'm about to tell you sounds crazy. So let's see at this example. It's a bit convoluted, but let's plow through it. So we have lots and lots of immediately invoked function expressions. We have set timeout with catch says 500, sleep for 1000, sleep for 1000, and sleep for 1000, and yet another sleep for 1000. And if we see how this code is being executed, then we can see that now it is executed in the order that we wanted it to execute. So first, what I'm about to tell you sounds crazy. It's synchronous code. Two, but you have to listen to me. It doesn't matter if it's like sleep 1000. We will still wait, but it will be a synchronous wait. Then your very lives depend on it. Then you see this isn't the first time, and only after that, after more than 4000 milliseconds, we will finally run our set timeout function, and it will console log our cache says 5 that we had this conversation. So no matter how long we push past our sleep, it will be executed last because it's asynchronous code. It's a task. It's not synchronous code. So to sum this up again, and then we will return to the question from the chat. So event loop, it waits for the entire call stack for our synchronous code to be empty. So it's constantly checking, is the call stack empty? If it is, then move the task from the event queue to the call stack, and then we execute it. If it's a microtask, a promise, then we will be executing microtasks until the microtask queue is empty. And that's why using the while true loop, we can block the execution of code in our browser because the call stack will be blocked. We will be executing microtask tasks, and more tasks will be added due to the while true loop. But if it's just a task, not a microtask, and set timeouts and set intervals are tasks, then we execute only one, and again check is the call stack empty. Then execute if it's empty, then again wait and check. So even though if we decide to add while true loop with set timeout or set interval functions, it will not block our execution of the code. So now let's see the question in the chat. So we have a set timeout, which accepts function B, and it will execute in 100 milliseconds. And next we have the function A, which is synchronous, and it has a let A invoked inside it, and then we are printing it to console log. So next we have the let B, which is the sum of several numbers. And so why function B was finished before function A. Let me see the result. So function B was executed first due to it being the synchronous code. It's a bit like what we have studied with promises. So let me check it in the console in my browser, and then I suppose I will just reshare the screen. So function B will be executing first because inside of it we have a synchronous code. So we are doing our calculations, console login B, and then we have our function A. And I suppose I will then put an explanation in the chat. After the lecture, I will break the code as in my example with synchronous and asynchronous code to make this explanation more understandable. So actually, it's a good interview question. I suppose you will be seeing something like that after you finish the lab, like why this code was executed before. That's a good question. I've marked it for myself, and after the lecture, I will provide the same explanation, the synchronous asynchronous code as for my example. So thank you. Okay, next, let's take one final look at the set timeout. So we can see in our example why it was run the very last, because the callback won't run. It will just be moved to the task queue after the delay. And that's why we are seeing the 5 number, the very, very last. So let's see if we want to execute something after the tasks have been finished. Can we use set timeout for that? Because lots of the time we want to execute something after some previous actions have been done. So we have the function cage says first. What I'm about to tell you sounds crazy. Okay, and now cage says second, but you have to listen to me. But it will not be done as we expect it to do. So we wait for a bit, but it could not be enough. And while it may work on our workstation, it may fail at another machine. So what is happening here? It is happening because in event loop, we are managing several things at the same time. So we are managing the tasks, the micro tasks, and also the request animation frame function. So we are managing the render. And you cannot be sure that set timeout will be run like exactly one out to wait for anything asynchronous. We can use a callback or an event, but we shall not be using set timeout for that, or we can get the results we were not hoping for, especially on different machines, on different internet connection, on different processes for our various users. And then the set interval, the last topic of today. So if we need to run something several times in a row, set interval is a very good option for that because it schedules the tasks to be running periodically. If we look at an example, we have the ticks and a sleep time. So if we take our cage says function and wrap it in the set interval, then we can be printing it to the console after a set amount of time, several times. So 100 milliseconds interval could mean that we are trying to run it, but it will not be exactly 100 milliseconds each time. As you can see, we are printing these milliseconds. And if you look at them, in the beginning, they are not exactly at 100 milliseconds. If the scheduled task takes longer, then the interval loop will consume the whole CPU time. So it shall be noted that even when we are running set interval and passing milliseconds to it, if there another code to be done, for example, long 90 milliseconds task here in the beginning, then the set interval will not be run at exactly 100 milliseconds every time. So you shall be wary of that. So it can be a good idea to use a recursive set timeout instead of set interval. Recursion is when the function is calling itself. So if we look at this example inside set timeout, we can see that if tix is less than 3, then we are executing the set timeout function again. And so it will be executing several times. And if you want your recursion to work correctly, if you don't want to have an indefinite loop, you will also need to have a condition to exit your recursion. So here we have if tix is less than 3, then we are running the set timeout, and at the very end of our function, we are also adding 1 to our tix count. So tix plus plus means that we are incrementing the tix by 1. And because we are incrementing it and we are checking if it is less than 3, after we have incremented the tix to equal 3, then our recursion will stop and we will exit our loop. If you don't have a condition to exit your recursion, then you will be adding and adding and adding more functions to your call stack, and then you will hit an error with something like execution stack depth exceeded. I suppose maybe you have already seen this error sometimes when we forget about the exit condition of a recursion, we can encounter this. And if we're using the recursive set timeout, then we will have proper 100 millisecond intervals between the end and the start of our loop. So this is all for today. I have also promised you uh, one more article, and I have promised you to write an explanation in the chat for the set timeout with function B and function A example, why function B is running first. It is actually very close to what we have just discussed today with different machines and with how set timeout is working. So before we go, are there any other questions for today's lecture?
I have a question that do we have to remember and aware all of this knowledge when we write code introduction?
Well, because we are not only JavaScript developers, but front-end developers, and mostly we will be working on web applications, yes, knowledge of the window object, of window document, of browser object model, it is a very big plus because it will make you aware of how browser is responding to what you are making it do with your code, and especially with performance optimization. But at least from my perspective, the main takeaway of today's lecture is actually the event loop part. Because even without knowing anything in detail about browser object model, you will not be lost. Like you can always look it up if you encounter, for example, some performance spike in your application. But without knowing how event loop works, this is a crucial part of this lecture. So when remembering and studying this material, I strongly recommend to focus on event loop, on microtasks, on tasks, and on request animation frames. So event loop is the key here. It's the most important topic to remember from the whole browser object model. Because in the future, if you need to work, for example, with window height or window width, you can always look it up. Like it's okay, we're all Googling something, but deep, good understanding of event loop is crucial when you are working with asynchronous code and all browser-related operations are synchronous.
Okay, I will remember that.
Okay, thank you for the question. So, do we have any other questions? Okay. Yes.
I have a question about in the comment. Yeah, my comment. Yeah,
Hmm.
I have a question. At comment. Yeah, comment. My comment. I have a question. I have this code. Yeah, function A, function B. Do you see that in chat?
Yeah. Yeah,
Yeah.
I can see it.
Yeah. And I wonder why I function B have a set timeout. So why function B was finished before function A?
Yeah,
Yeah.
as I told before, I will write an explanation to this by dividing it to synchronous and asynchronous code in the chat after the lecture to make it more easily understandable, as we did with our previous example where I have split it to synchronous and asynchronous parts. So yeah,
Okay.
I have liked the post to not forget about it, and I will write the division in the chat to explain how it works step by step, because it's really a good example.
Oh, uh, okay. Mm.
Hmm. So I
Yeah.
have now that. Yes.
No, no, no.
Hmm. So I have noted this task and I will write it sometime later today to give you a full explanation which part is synchronous, which part is asynchronous, and why we have this result, because I suppose, yeah, you will encounter something like this in the coding interview in the future. Okay, do we have any other questions? Okay, if we have no more questions, then I suppose that's all for today. I understand that this topic may be a bit difficult at first, but I strongly recommend to view the video I have linked on the event loop by Jake Archibald and to read the articles I've linked on how our monitors actually handle the request animation frame function and how they are updating and repainting the pixels. And I will follow up on the questions from the chat. And I suppose then that it was all for today, and I will see you on Wednesday. Have a great evening.
Yeah. Thank you a lot.
Thanks.
Have a
Yeah.
good day.
Bye.